Okay, good morning, Warriors, for lesson 11.3, day 2. It's going to be the final lesson of the school year for 2020. Um, Picking up off of where we left off yesterday, our essential ideas are still to analyze different strategies to solve exponential and logarithmic equations. We did almost all the examples of exponentials yesterday. We did a few of logarithmic yesterday. Today, we're first going to tackle what happens if the base is unknown. Well, there's a couple examples here. Bottom line, we had a log base x of 24 equals 6.7. Okay, what we want to do, because I have a variable inside my log somewhere, I want to switch form into an exponential, which is the base of the log to the exponent of 6.7 equals 24. Now what we're going to do is, because I have x to the 6.7 equals 24, I don't want to take the 6.7 root. So rather than do that, I'm going to raise both sides of this equation to 1 over 6.7. So when I take 6.7 times 1 over 6.7, I get x to the first power. And I can type into my calculator 24, and I can raise that to the 1 over 6.7. Missing a little dash here, or a fraction bar. And if you're using the Charlie Cheapo calculators, just please be careful that when you hit the caret symbol, you put the 1 divided by 6.7 in parentheses. Otherwise, for the most, you will be getting your answer wrong. Okay? Now, in this third set, explain why both sides are raised to that power. Well, basically, what I want to do is, the goal here is to get the exponent on x to be a power of 1. And just remember, what you do to one side of an equation, you must do to the other side of the equation. So that's why I raised both sides to 1 over 6.7. And what we're going to do here is we're going to run into a couple examples. I'm going to switch over to my webcam. And I have these. Now, I'm not going to be doing all these examples. Notice I have 3 and 4 on top. That's because I'm going to do 1 and 2 first. And when we're looking at a log base x of 50 equals 3, I have a variable in my log. So I'm going to take the base to the exponent equals the argument. You've solved these for many, many times. So what we're going to do is we need to take the cubed root. To get rid of an x cubed, we take the cubed root. Well, the cubed root of 50, so x is approximately equal to 3.684 would be my answer to that one. Now when I look over here, because this was an integer number, yeah, I did use the root. But over here, I have my log, so I'm going to say x to the 1/2 power equals 28. Well, how do I get rid of that 1/2 power? Well, to get rid of a 1/2 power, 1/2 times 2. So if I square both sides, 1/2 times 2 gives me x to the first power equals 28 squared is 784. Okay? And what I'm going to do is I'm going to erase these two examples here quick. I'm going to do number 3 yet. And number 4 I'm not going to do. I'm going to let you do that one on your own. And you can check your answers in its learning with the filled out notes. But when I'm looking here again, I have my log isolated with a variable in the log. So I'm going to switch forms. It's going to be x minus 2. That whole base is to the exponent of 4.1. That equals 23. Well, I don't want to take the 4.1 root of that. Easier thing to think about is if I take that power to another power of 1 over 4.1, and if I do it to that side, I have to do it to this side. What happens is these two exponents give me x minus 2 to the first power, and that's going to approximately be equal to, if I type this into my calculator, 23 raised to the 1 over 4.1 power is approximately 2.148. And the decimals keep going on. I'm just going to round it off to 3. I need to add my 2 across. So in this case, x is approximately equal to 4.148. And this one I'm going to let you try on your own. I encourage you to do that, and you can check the online notes for your answers. And I'm going to hit pause. Okay, so after those couple examples, like I said yesterday, I'm not going to do all these examples. On this page, there's actually 8 of them. I'm going to do 4. And when I turn the screen around, the examples I'm going to do in order are going to be 1, 3, 4, and number 8. And then after that, I'm going to write 2, 5, 6, and 7. I'll just write the problems up there for those of you that can't print the notes, that you can write down and try them on your own and check your answers on its the filled out notes on its learning. So basically, 11.1 we analyzed when to rewrite equations and when to leave it as is. We're going to look at this again. Okay. Circle the box which indicates what you want to rewrite in the other form. Well, basically, usually I rewrite the equation almost every time. What we're going to do is I'm going to switch over to my webcam. I got 2 examples, and I'm going to pause. I'm going to write the next 2. They all go a little bit, they're all done a little bit differently, but notice here I have a log. The log is by itself, it equals a half, okay? And I have a variable inside my log. So anytime I got a variable in my log, I want to change form into an exponential. So I'm going to say this is 4 to the 1/2 equals x plus 3. Okay, my base to the exponent equals the inside. Now, don't wig out, oh, I need my calculator for 4 to the half power. No, you don't. Because that's a fraction exponent, that's just the square root of 4 equals x plus 3. Well, the square root of 4 is 2 equals x plus 3, and then I'm going to subtract 3 across, so x must equal -1 in this case, okay? Now when I look at number 3, same thing, except now my unknown's in the base. So all I'm going to do is I'm going to rewrite it because I have a variable in my log. I'm going to rewrite it as an exponential. So I have quantity x plus 2, because the entire base, whatever is down here, goes to that exponent, equals 7.1. Well, because I don't have a fraction here, I can get rid of a cubed root real easy by just taking the cubed root on both sides. So I get x plus 2 is approximately equal to the cubed root of 7.1 is about 1.922. Now I have to subtract 2 from both sides. So in the end, x is approximately equal to -0.078. Okay, and I'm going to pause this, write my next 2 examples on for you. Here in number 4, we didn't do a lot with natural logs, but people freak out about this. And the natural log is just a base E log. So if I change the form of this, the base of a natural log is E to the power of 3.8 equals x plus 4. Okay, just to give you an idea, another way to write this, which we never do, would be log base E of x plus 4 equals 3.8. But because all these natural logs are always base E, it's just easier to write ln for natural log rather than log base E. Okay, so anytime you see that ln, it's just a base E. Well, when I change it, well, I can type this in because remember E is 2.72-ish, so I can type that right into my calculator, and my calculator's not in my head here. I know E to the 3.8 is approximately 44.701. That's approximately what x plus 4 equals. Well, now I need to subtract 4 from both sides, so x is approximately equal to 40.701. Okay, last example I'm going to do on this page is number 8. The other thing, notice that's what I call a naked log. There's no base written on the log. Whenever that happens with an LOG, it's an invisible 10 sitting there, okay? So I do have a variable inside that log, so I'm going to change it into an exponential by saying the base of 10 to the 1.3 equals 4 minus x, and 10 to the 1.3 power is approximately 19.953. That's about what 4 minus x equals. I would subtract 4 from both sides, and I would get 15.953. That's approximately what negative x is, and x isn't alone, so x is actually approximately equal to negative 15.953. Okay? And I'm just going to write the other 4 problems that I did not do on the board for you here, and you can write them down and hit pause and try them and check them on It's Learning. As I promised you, here's the 4 examples on that page that I did not do. I highly encourage you to write them down quick, give them a shot, go on to the filled out notes on It's Learning and see how you did. I have worked out solutions to all 4 of them on there. So give those a try, and I will be back soon. A final page. When we're solving logs, okay, there are those pesky things called extraneous solutions. Well, what an extraneous solution is after I solve it and I find out what x equals, I need to plug that value for x back into my original equation anywhere I have an x. And if the solution produces a negative number in the argument, or a negative number in the base, we need to eliminate that solution as an extraneous solution because it's not a true solution. So there's 6 problems on this page. I'm going to do numbers 2, 3, and 6 as examples, and then I'm going to go back and I'm going to write the last 3 on the board for you to try on your own. Okay, let me get my webcam going here. And what we have here, again, these are getting crafty. Now I have multiple logs in here again. Notice I have 2 logs. I can't rewrite a log into an exponential equation until there's only 1 log in the equation. So I need to see this minus. Well, that means I need to condense those 2 into a log, still base 5, but it's the first argument divided by the second argument. That equals 2. Now I'm down to 1 log, equaling a number, and there's a variable in my log, so now I'm going to rewrite it. I'm going to rewrite it to 5 squared equals x squared over 4. Well, when I look at this, now I'm going to solve this. I know 5 squared is 25. That equals x squared over 4. Well, what I'm going to do is I'm going to multiply both sides of this equation times 4. So I have x squared equals 100. Then I'm going to square root and find out x equals square root of 100 is 10. Okay, and what I need to do is I need to take this 10 and I need to come back up here. Okay. 10 squared, that gives me 100 inside this log because that number is positive. I'm all good. This one doesn't have a variable in it. Therefore, x equals 10 is my solution. Okay. When I look over here at number 3, again, 2 logs. These 2 logs are added. So I'm going to do an extra step in here, not mental math. But when I condense these 2, I really have log base 3, and I need to multiply x minus 4 times x plus 2, because when I condense it, it's the product of these 2 logs that are going to equal 3. Well, really, that gives me log base 3. I want to multiply these together in here because that's not 0 over there. So I want to multiply those together, and I get x squared minus 2x minus 8 equals 3. Excuse me. Now I'm gonna change its form to the base to the exponent equaling the argument. And this is just another way to say 27. So 27 equals x squared minus 2x minus 8. It's a quadratic, got to get it equal to 0, so I got to subtract that over. 0 equals x squared minus 2x. Negative 27, negative 8, that's negative 35. And now I need to try to factor this little booger. And I get x, one's plus, one's minus. 7 times 5 is 35, and I need more negatives. Then I need positives, okay? And I'm going to say this looks like x equals negative 5, and it looks like x equals 7. Well, I need to come back and I need to plug this negative 5 into every log, okay? So what is negative 5 minus 4? That gives me a negative 9 inside this log. So because this log is going to have a negative argument, that is an extraneous solution I must throw out. I don't even have to check it in the other one because I got a negative in the first one already. So I'm going to take 7. 7 minus 4, well, that gives me a 3. That's okay. And 7 plus 2, that gives me a positive 9 in there. So my arguments all stayed positive. So this only has the solution of x equals 7. Okay, I'm going to erase here for my final example. Final example here is number 6. Okay, and after I did this one, we've done a few of these. These are the 3 problems I'm not going to do that I encourage you when I'm done with this video to try on your own before you do your homework, just to make sure you're doing things right. Check your answers on It's Learning. There's a couple tricks in here that are going on, and if you can't figure them out, please come on to the office hours. We really miss you guys coming in, and not many people are visiting us, but so when I'm looking here, I have all kinds of logs all over the place. Well, I only have 1 log on the right, but I have 2 on the left, and they're added together. So I'm going to condense those 2 little buggers together on the left, and they're natural logs. So that's going to be the natural log. And again, I'm going to show you an extra step when I condense x minus 2, because I'm multiplying these 2 arguments into the 1 log to get a natural log of 2x plus 24. Okay, now this is a step. I usually would mentally multiply this and jump straight to here, but I wanted to show you, and that's going to give me x squared. 2, 3 is minus 5x plus 6 equals the ln of 2x plus 24. Now check it out. I have a log, 1 log equaling 1 log. They are the same base logs because they're both base e. They're natural logs. Well, that means I don't have to rewrite this thing at all. I just need to say what makes my arguments the same. So I just set my arguments equal to each other. Okay? And I got a quadratic, so I need to move everything over. So I'm going to have x squared. I'm going to subtract 2x over to give me minus 7x. I'm going to subtract 24 over, and that should give me what? Minus 18 equals 0, I believe. And I need to try to factor this. Well, what are the 2 numbers that multiply to give me 18 that when I subtract them I get negative 7? 2 minus 9. So this is going to go x minus 9 times x plus 2 equals 0. Again, there's my x squared. There's my negative 18. Negative 9 plus 2 gives me my negative 7. So it appears my solutions are x equals 9 and x equals negative 2. But I need to check them to see if they're extraneous solutions, because remember, the inside, the argument of a log, has to be a positive number greater than 0. So when I put positive 9, 9 minus 3, that gives me a 6. That's okay. 9 minus 2, that gives me 7. That's okay. And over here, 9 times 2 is 18 plus 24. Well, that's still going to be a positive number. So 9 works. When I put negative 2 in here, negative 2 minus 3 is negative 5. Whoop, I get a negative argument. Can't have that. That's an extraneous solution. So I'm going to throw that one away. Okay? And again, please try these on your own before you do your homework and check them on It's Learning. Don't really have many parting words for you guys other than I know I can speak for Mr. Myers at the same time. Truly miss you guys. Do not like teaching this way. I miss seeing you every day, miss interacting with you every day. Hopefully, we're back in the fall and everything's normal. So, from there, I sign off from my basement for the 2020 school year. Have a great summer, guys. We'll talk to you later.